Hi, I'm Kirralise Hansford, and I'm going to be talking you through my poster titled Somatosensory Response Changes During Illusory Finger Stretching, a Registered Report. Resizing illusions can be delivered through augmented reality to change the perceived size of a body part. You can see a schematic of the augmented reality system we used in Figure 1, and if you use the QR code, it will take you to a video showing the resizing illusion on a participant's hand. The neural underpinnings of resizing illusions are currently undefined, but they can provide analgesia for individuals living with chronic pain. There are two main theories explaining this illusory analgesia. The somatosensory blurring hypothesis posits that the cortical representation of a painful body part is blurred, and viewing this or seeing it in a resized image can sharpen the representation, which can then reduce pain. The magnification hypothesis posits that there's a reduced cortical representation of the painful body part, and increasing this through magnifying or resizing the body part can reduce pain. This study aimed to understand the neural underpinnings of resizing illusions in participants without chronic pain to provide an empirical basis for later investigations in chronic pain samples. 46 participants underwent 4 different resizing conditions, which can be seen in Figure 2. Whilst undergoing these conditions, participants were fitted with an EEG cap and a vibrotactile stimulator taped to either their right index or middle finger, which can be seen in Figure 3. This stimulator vibrated during each trial to elicit a steady-state evoked potential response. After each condition, the participants completed a questionnaire measuring their illusory experience and their disownership experience. Our first hypothesis was that there would be a greater illusory experience in the multisensory condition compared to the non-illusion condition, and there would be greater illusory experience in the multisensory condition compared to the non-illusion tactile condition. As can be seen in the left panel of Figure 4, participants experienced a significantly stronger illusion in the multisensory condition compared to both the non-illusion and non-illusion tactile conditions, and also compared to the unimodal visual condition, supporting hypotheses 1A and B. The right panel of Figure 4 shows the disownership scores across conditions, and you can see a significantly greater experience of disownership in the unimodal visual condition compared to all other conditions, which likely explains why illusory experience in this condition was not similar to that of the multisensory condition. Our second hypothesis was that there would be a significant difference in SSEP response across our electrodes of interest across all conditions. A Friedman test found a significant overall effect of condition supporting hypothesis 2. Our subsequent hypotheses were that there would be significant differences in SSEP response when comparing the multisensory condition to the non-illusion condition, the unimodal visual condition to the non-illusion condition, but not when comparing the non-illusion tactile to the non-illusion condition. Post hoc tests found no significant differences when comparing across all conditions, meaning hypotheses 2A and B were unsupported, whilst hypothesis 2C was supported. The left panel of Figure 5 shows the 26 Hz signal with the head plots and electrodes of interest for each condition, whilst the right panel shows the SSEP amplitudes per condition. To conclude, we found significant differences in subjective experience between the non-illusion and multisensory illusion conditions, and our EEG data, which measured somatosensory steady-state evoked potential responses, showed reduced amplitudes in the illusory conditions compared to the non-illusion conditions, but without reaching statistical significance. These findings demonstrate a potential sharpening of the neural representation as a result of illusory stretching in participants without chronic pain, providing a basis for investigations in a chronic pain population. Although we didn't find significant differences here, due to likely small effect sizes, people living with chronic pain are thought to have more diffuse neural representations of their affected body parts, so it could be that we see significant differences in a clinical population rather than this population. You can access our Stage 2 manuscript by following the QR code here. Thank you for listening.